For part A of this problem, a key part of the problem statement says that the voltage drop across the capacitor is equal to the voltage drop across the resistor. Okay. Well, I know that the loop rule tells me the voltage drop across the resistor plus the voltage drop across the capacitor has to equal the EMF, right? If I draw this out, so here's the EMF, here's the switch, here's the resistor, here's the capacitor, right? If I take that voltage drop plus that voltage drop, it's got to equal that voltage difference. So if the EMF is 12, and these are both equal to each other, then they both have to be 6, right? So the voltage drop across the resistor must be 6 volts. Alright, so given that, I know that the voltage drop across the resistor, well, I know the current, I, is equal to I max times e to the minus t over RC. Right? Well, if I multiply both sides of this equation by R, then that R cancels with that R. And this, Ri, that's the voltage drop across the resistor. So I've got 6 is equal to 12 times e to the minus t over Rc. Or 0.5 is e to the minus t over Rc. Okay? So then I take the natural log of both sides. And that gives me minus 0.693 is equal to the time. Now we're told the time is 1.1 times 10 to the minus 5 seconds. And we're also told the resistance is 3. So the capacitance we don't know. So if I solve that equation for the capacitance, I get that the capacitance is equal to 1.1 times 10 to the minus 5. I'm getting rid of both the minus signs here. Divided by 0.693 times 3. And that is 5.3 times 10 to the minus 6 farads. Or 5.3 microfarads, if you'd rather. Okay, so there's part A. Oops, already did that. Part B says, at what time is the current equal to 1% of its initial value? Well, our equation for current is that I is equal to I max times e to the minus t over Rc. And that I max, well, that's the initial value, right? Because remember how RC circuits work. When you first close the switch S up here, and the capacitor is uncharged, that is when current is flowing freely. And the current through the resistor is just the EMF divided by the resistance. So I max is that initial value. So if we're at 1% of the initial value, that means I is equal to 0.01 I max. And then the I max can cancel out, and I'm left with 0.01 is equal to e to the minus t over Rc. Well, now I know R and C, and I got to solve for T. But it's the same kind of logic, the same kind of math that we did above. So I take the natural log of both sides, and when I do that, I get minus 4.605 is equal to minus T over 3 times 5.3 microfarads. Okay, and if I solve for T, I get T is equal to 7.3 times 10 to the minus 5 seconds.